Hey everyone, it's Bob Crossan, Senior Managing Editor for Water and Waste Digest. I am joined today by Tad Bohannan. He is the CEO of Central Arkansas Water, as well as Tom Crowley. He is a project manager with Carollo Engineers. And we're going to be talking about their WWD Top Project winning project, which was the Ozark Point Water Treatment Plant. So thank you both for being here. I appreciate you taking the time and congratulations on a top project for 2022.
Thank you.
Thank you very much. We were excited.
Yeah, well, it's been a big year for you in Central Arkansas Water. You had two of your employees were young professionals named, and now you have a top project. So congratulations on a great year for Central Arkansas. You guys have things going pretty well down there, it sounds like.
We work hard, but it's nice to get that recognition from time to time. So thank you.
Yeah. Well, why don't we start with you, Tad, on explaining this plant and the people that it's going to impact and kind of your system. Where does this fit into the grand scheme for Central Arkansas Water, and what's the community impact and who's impacted by the project?
Sure. The Ozark Point treatment plant has been providing water to Little Rock, which is the capital of Arkansas, right in the middle of the state. That's where the name Central Arkansas Water comes from, since the 1890s. And so it's been around and it's been part of the community for over 100 years, which is really important to us. We serve water to almost 500,000 people, about 500,000 people. And we have a service area of 721 miles and almost 2,700 miles of pipe. So, infrastructure is a big part of what we have to focus on. And what's one of the things that's really interesting, particularly in the state of Arkansas with the Ozark plant, it is a totally gravity feed system. Its source water, for the most part, comes from a lake that was built back in the 1930s. And it's gravity feed for 33 miles from that lake to the treatment plant. And then the water flows through the treatment plant and then down the hill into the community of the old historic part of downtown. So, we are affecting, 14 cities and 7 counties. That's how we provide water to in Central Arkansas. And like I said earlier, it's about 500,000 people. And a large percentage, 30%, 25 to 30% of our water comes through this plant. And it's exciting for us because it has been in use for so long. And that's one of the things we mentioned to Carollo Engineers was, we wanted to keep that historical basis for it. And they were able to do that. We were really excited about that. But that's where we are. That's who we serve. And we were very excited about this project. And I will tell you, we had an open house after the project before we started, and then another one after the project was completed. This plant sits in a historic neighborhood. All the houses around it are, 75 to 80 years old. And so it's in a historic area. And the neighbors that came to tour were just really, really excited about what they saw and what they were and how the project was completed.
One, that's really cool. We'll dig into that here a little bit later on the historic neighborhood aspect. But you mentioned just how old this facility was, and I'm sure it's been updated over time. But usually those types of plants, they do run into capacity issues or just aging infrastructure in general. What were some of the catalysts that led you to want to upgrade this facility or need to upgrade this facility?
Sure, and that's a great question, and I appreciate you asking it. From a water quality standpoint, the impetus of the reason that we wanted to do this is we were getting short circuiting in the treatment process. So particularly in the settling basins, not all the water had the time necessary for the settling basins to fully settle out the turbidity, less than, I guess is the best way to say it. But it is an old plant, and most of the improvements that have been done to it over the years were either electrical in nature or chemical feed in nature, but we hadn't ever really done a wholesale improvement of the basins themselves. It's really interesting, and Tom will tell you more about that in a little bit, I'm sure. But the concrete is really old, and so there was some spalling and some different things happening with the concrete there. But from a water quality standpoint, the biggest emphasis was we had short circuiting going on.
Yeah, well, Tom, why don't we jump right into that then? The age
Sure.
of this facility, how did that factor into the challenges that were presented to you? You talked about the old concrete and some spalling. What were some of the challenges that you ran into in upgrading this facility?
Yeah, so there are several challenges. I would say that the first one was to determine what we had and what could be reused and what could not. So one of the biggest concerns we had early on was our concept to reduce the short circuiting was to completely reconstruct the treatment basins. Now, what we wanted to do was keep the bathtub, basically, the perimeter walls, which were the original construction from 1880. Matter of fact, we had investigated it, determined, got some old photographs. Most of it was a mass concrete wall that was a buttress design with basically a really thin slab underneath. So we had to determine what was underneath the treatment basins. Could that support what we were doing? The buttress wall was actually built it's a mass concrete wall. It was built by mules. So it was very interesting. So the concern that we have is that wall good for another 100 years or so, which is what we suspect we'd like to have the life cycle associated with any new concrete that we put in. So we took a petrographic analysis, determined that there was really no alkali silica reaction, which is a concrete cancer, basically, that we were outside of some spalling and some rehabilitation, that the concrete was good. We had determined that the foundation was good. So what we came up with was building some new walls and rearranging the basins to reduce short circuiting, increase plug flow, and provide a very good environment for settling. They're an alum lime plant, and that's really important because alum doesn't settle all that great, particularly if you don't add polymer. So they really wanted to make sure that they didn't have to add any more chemicals, and that we could promote some really good settling. One of the challenges that we had, particularly from the electrical side, is that a lot of that was not up to code. A lot of that was old wire. So we had to do a lot of investigations in determining what we had before we could really put out a biddable set of plans and specs to the contractor. So it was a lot of investigation, a lot of homework that we had to do before we put out any sort of plans and specs to maintain the existing condition of the filter, the existing appearance of the filter building, and retrofit the basins to have them do what we wanted them to do.
You talked a little bit about the filters, and that was one of the things in the nomination form that I found a little bit interesting, was that you chose rinse to wash over filter to wash waste filters. Sorry, filter to waste filters. What was the reasoning behind that? How did you identify where you wanted to go with that, and why did you make that decision?
So whenever you start out with a treatment project, my goals are to establish what are the must-haves. So those are obviously regulatory compliance, right? And then there are the may-haves. And one of the goals that Central Arkansas Water has placed on itself is to eventually look to work towards meeting partnership for safe drinking water standards with respect to their treatment basins, which we were able to achieve with the basin improvements, but the filtration effluent turbidity is also a standard that they were shooting for. We had made some investigations, led us to make some changes in their operational settings on their filters. So for example, they were running a low rate backwash without a collapsed pulse. And that was causing them some secondary spikes in their filters. What we were able to do is with some investigations, we were able to reduce the backwash time when they were actually getting their filters too clean. So we went in, made some changes to the programming, implemented rinse to waste, and did some filter monitoring. And in that, we determined that absolutely regulatory compliance is there. There may be some periods of time where the filters aren't robust enough to meet partnership for safe. We weren't really willing to sign off on rinse to waste being the solution to achieving the partnership for safe drinking water. But given the budget that we had, the age of the facility, and the amount of work that needed to be done in the filter building to maintain the treatment process and improve the treatment process, we decided that a rinse to waste was adequate for this facility, and that if in the future they wanted to implement filter to waste, we developed the plan to do that, and they have a knowledge of what the capital costs are to do that.
Well, I want to bounce back to something that Tad had talked about early on, the historic neighborhood and just kind of the location. One of the things here too was making sure that the facility retained some of that historical look and feel. Tad, could you talk about why that was so important to you? And it sounds like, Tom, you have some challenges related to even managing that aspect of this project as well.
You come out the gate of the plant and you look at any of the houses there, and they're just these beautiful older homes that are being maintained in the area they are. So it was required, and there's a plaque on the wall about the historic nature of the facility, and that wanted to be maintained. And I will tell you, Carollo and the construction crews did a great job of managing the projects within an engaged neighborhood. I mean, they were watching this project very closely as to what was going on, and so they did a great job of not just keeping the noise down, which is the normal complaints, but also being available to ask questions of people, that historic nature was going to be preserved, and that has come to true. The people have been through it, and they are really excited and proud of the work that was done.
Tom, do you want to expand on the
Absolutely.
historical significance?
Thanks, Tad. Yes, it is part of the community, and that was very important to them. So when we went into the design, we had that up front, is that we want to maintain and improve the filter building for another 100 years, right? That was the philosophy behind it. And I think Tad and I both want to acknowledge who the contractor was. It's Max Foot Construction Company. We wouldn't be here, honestly, without them. They were an excellent partner. We sat down with a CAW and the loan officers and established specific contingencies for where we thought we might run into problems. And lo and behold, we did. So one of the challenges that we had is that this filter building was actually built in phases. I would say the first one was built in the 30s as part of part of the work programs that they had during the Great Depression. Then the next phases were built in the 50s, and then final phases were built in the 60s. But they all maintained kind of the Art Deco philosophy that they had back in the 1932, 33 when the first filters were built. So we wanted to maintain that Art Deco appearance. There was a lot of challenges in that the fascia was wearing down. We didn't know how many bricks we'd have to replace, how many lintels we'd have to replace until we actually got in and dug into it. That's where the contingencies came in place. Another thing was the roof, the challenges with the roof, the way they had built this first phase with a cast in place roof lended to some interior corrosion that we were not aware of until we started replacing the roof. Contingencies went into that. And then finally, the elevator was also a challenge because none of that was to code. It's very important when you rebuild an elevator to make it to code. There was a lot of unforeseen issues there that the contingencies were able to take care of. So I think proper prior planning, as far as knowing what our unknowns are and establishing what we would potentially run into construction, led to a really successful project with both the owner and the contractor. Another thing that I wanted to add is what Tad and I, when we looked at the filter building, we wanted to not necessarily implement it right away, but we wanted to implement ADA access and actually open it potentially in the future for allowing public tours. Now, Tad did mention that there was tours in the neighborhood groups before and after, but I think there may be a longer term plan to open up the facility for public tours, because it really is a local treasure.
That's fantastic. Well, I appreciate you both taking so much time to spend with me today and talk a little bit more about this project in detail and getting some of the nitty gritty even too. And so I really appreciate you guys taking the time to speak with me on that today. And for everyone who's watching, definitely check out our video description below. We'll have some more details on this project that you can read about. And once more to Tad and Tom, thank you so much for being here.
Thank you. It's a
Thank you
pleasure.
very much. Honored to be here.